We'll be starting today's lesson with some of the basic revision that we'll be doing now. So, you can search for different cheat sheets available online, and you can refer to any of those. So basically, this is from IntelliPath, and I'm not promoting this IntelliPath. There are few more. Like for you can also get it from Dojo Data Science. So there are many. Okay, so this is the one having the basic concepts only. So that's why I have preferred this one. So last time we did cover like data types. What are the different data types? So in that we had integer, list, tuple, string, sets, dictionaries, and basically list, tuple, dictionary, and set. These are a type of containers which contains certain data sets. Then we also covered operators. So in that we had arithmetic operators, and there were some relational operators. Okay, so arithmetic basically is plus, minus, multiplication, division, modulus, all those things. Double star is basically raised to the power. It is power function. And then we have comparison operator, which is this is basically is going to give us a boolean value, double equal to, not equals to, greater than, less than. So these are comparison operator, and basically you can see its usage in if conditions. And then we have boolean operators, which basically gave us true or false. And coming to list, sorry, operations, we have list when we like what different things we can perform. So to make a list, you can just simply write list is equals to and then square brackets. So that will make an empty list for you. And to access any element of a list, you can use indexes for that. And if you pass the name of the list, and in square bracket if you pass any number or the index, so it will give the element at that particular index or address in that given list. To add a new element, in the end we use dot append function, and to remove any element from any given position, we use remove or pop. Then we had string. Similarly, on string we can perform iteration. Iteration basically refers to the movement from one particular location to other. And for dictionary we use curly brackets, and in dictionary we always have key value pair. And then we had gone through the flow control methods, which basically refers to the if else statements, where we give certain conditions, and if the condition is true, we execute certain set of lines, and if it is false, then we execute certain set of lines. One thing that you must take care while going through Python is that in Python indentation is very, very important. As you see in this, there is no indentation. This is basically not the correct format of writing, but this is at the bottom. You see the for loop. They have indented with a space. So indentation basically refers to a sub body that is referred under different sections. So suppose if I'm writing if price is greater than 7,000 colon, then whatever the number that is coming print by that we are writing is that should be indented, and it should be written inside the if block. So we had done this, and then there are different types of if usage, like if simply if, then, or we can use if else or if else if. So if else if is basically elif we write. And then we did certain loops basically are used to repeat certain number of times. If you want to repeat a given set of code certain number of times, then we use loops, and it could be a for loop or while loop. And then we did functions are basically small modules or small programs that help you to make or divide your programs into sub programs, and basically it helps you in debugging. So if there is an error whole program, you need not to go checking for the whole program, but instead whatever the section or whatever the function is not performing well, you can go to that function and change it. Then we had also learned lambda function. Lambda function is basically uh, used for one-liner functions. So as you can see, the keyword that is used for the lambda function is lambda, and here you see it's written a comma b colon a plus b. So that means a comma b is the name of the variables on which the lambda function is being applied, and the function is a plus b. So whatever the value that is being calculated from here is going to be returned from this function. When we go for the comments, we can use single line comment that is done by hash symbol, and the multi-line comment if you want, so you can use combination of triple single quotes or triple double quotes. And there are certain general operations that you can use as such as range function. So range is basically going to give us a range of number, so it can take one or two arguments, or sometimes it can also take three arguments. So you can give starting point, ending point, and the steps that is required to count. So suppose here range 5 it is given, so we get the numbers from 0, 1, 2, 3, 4. So the last number is not included in that. Similarly, if you want to get anything input, we use input function, and whatever that is written in this double quotes is basically going to be printed on the screen, and it is just a simple message. So whatever message you want to print, you can directly use print command. Len is a function that gives you the length of any item. Min is going to give the minimum, max, sum. And similarly, there is another function called as sorted that is going to sort the list. And for the file operation, we have not done yet. We'll be doing it. Try and catch block is basically not covered up to now. We'll be covering it at later stage. Okay. So this was one such cheat code. There are many other cheat codes available, and you can just Google and check whatever feels good for you. So here are some string functions. Split is a very important function where suppose uh, there are spaces between two words and you want to extract each word as an item for a list, you can use split function. So split is going to split the sentence on the basis of certain delimiter that you give. And then we have upper and lower function to change the cases. We have membership operators, that is in and not in. So these are some functions that are very important, and you can always revise. So today's topic, what we are going to cover is we'll be covering NumPy today, and tomorrow we'll be covering pandas. So what basically NumPy and panda is, so it is like some small module or small packages that are built separately and that you can plug and play with the Python. So Python is more importantly why is it used is because of these packages. There are different packages that can be added to the Python based language, and you can use extend the capability of Python to that thing. So if you remember, there is a game called as Lego game. I'll show you. Lego blocks. So these are the blocks, right? So suppose one particular block is Python, and these are the different blocks. So you can club in these blocks and make different projects or make different shapes and size shapes, or you can say suppose this is structure of pyramid. Okay, so one of them is Python, and other blocks are different modules that or different packages that you are using to build your project, right? So Python is one such block, and the capability of it to get clubbed with other modules is one such feature which makes Python more interesting and more famous than any other language. So we'll be covering today NumPy. So what basically NumPy is, numerical Python. So NumPy is basically a package that is used for arrays. So if I say array, so array is a type of data type. It's a data type which contains item of same type. So if somebody asks what is an array, so array is a data type, and it refers to the collection of elements of same data. So let me show you an example here. So if I make a list here, 1, 2, 3, and then we have A, and then we have B. So this basically is a list, right? Anything that is written between square brackets is a list. So here the name of our list is A, and it has two different types of data. First is integer and other is character. But if you talk about array, it is going to have either character or strings or integer. Like there is no mixing of different data types. It will, all the elements will have will be of same data type. Okay. NumPy is very fast. That is the reason that means we prefer NumPy over any other normal Python. So NumPy is basically used whenever there is a requirement for arrays. We want to work for arrays, or we want to work with different matrices. So if you remember your basic uh, class 10th, there was a chapter in maths. So that was matrices. Okay, I'll show you just a second. Now you see, if you can see this was, if you just consider one particular line, just one line, so it is very similar to list. Like if you just consider 1 2 3, or you just consider 6 minus 2 5, so this is a list. Now you are clubbing these two different lists and making a 2D structure, something like a 2D structure. So it becomes uh, two-dimensional. So now these kind of things are basically in maths, if you call it, these are called as matrices. Okay. So in, if I talk about matrix dimensions, so if you can see, it is the dimension basically refers there are how many rows and how many columns. If you see this black picture here, and this the matrix has the elements as 2, 7 and minus 4, and the second row has 6, 3 and 5. Okay. If you want to talk about column wise, we have three columns. First column has 2 and 6, second column has 7 and 3, third column has minus 4 and 5. So if I talk simply, how many rows and how many columns are there in this given matrix, we have two rows and three columns. So we'll be writing it as it is a matrix of 2 cross 3, that is two rows and three columns. Okay, so that is one way. Let me add so two rows and one column. So suppose this was my matrix and I have written 1 2 3 4 5 and 6. So this is one such matrix, and the number of rows are defined by, these are the number of rows. So this is R1 and this is R2. And if we talk of columns, can you see the screens? I suppose no. Okay, just a second.
Yes, yes.
uh,
Yes, Bridge, you can see.
okay, I have to change it to some other presentation. Just a second.
Are you sharing the
Yeah,
matrices?
yeah, I'm just trying to change it. Just a second. Okay, can you see?
Yes, I can see matrices.
But it's blinking. I don't know why. Just a second.
I can see the this one whiteboard kind of thing.
Yeah, just a second. I'm trying to reshare my screen. So just let me know. Is it visible now? Not yet. Just a second.
Not yet.
Okay. So now suppose our matrix is this, and we have elements 1, 2, 3, and 4, 5, and 6. So this is a simple plain matrix, and this is row 1, this is row 2, and if you talk of column wise, this is column 1, this is column 2, and this is column 3. So if we talk about the shape and size, we have 2 cross 3 matrix, that is size of our matrix. Now, if I talk about the indices, so if we consider this particular just 1, 3, and 5, if I talk of this, so what we have is we just have a plain list with the numbers 1, 3, and 5. And if you talk about the bottom portion, we have 2, 4, and 6. This is another list. Okay. So what we have done here is we have combined these two into one single block, and that made it a matrix. Okay. Now, this was our final matrix, and if we call it as row 1, and this is as a C1, C2, and C3, and let's divide it into blocks, and this is as R2. Now, if you remember the Excel sheets, so these are the cell addresses that you can see here at the bottom. So these are the cell addresses. So this becomes R1 and C1, R1 and C2. This become R2 and C1. This becomes R1 and C2. This becomes
R2C.
R2 C2. So row comma column. So that is going to give us the address. Okay. And indirectly that address, if we refer at like if you remember in list, we start counting from 0. So this becomes 0, this becomes 0, this becomes, sorry, this becomes 1, this becomes 0, and this becomes 1 and 2. So our number addition, the location becomes 0 comma 0, this is 0 1, and this is 0 2, this is 1 0, this is 1 1, and this is 1 2. So this is how you find the address of any particular element. So in this list, suppose our element is 1, we have 2, 5, 8, 7, minus 6. So the address for this is 1 is basically 0 row. This is okay. This is 0 1. This is 0 2. This is 1 0. This is 2 0. Sorry, 1 1, and this is 1 2. So this is the basic understanding how you can see the addresses are, and this is the address that is going to fetch this particular element. So if you want to fetch out 0 1, it is going to give us this. If you fetch out 1 2, it is going to give us minus 6. So that's the basic funda of indexes or the addresses in NumPy. Okay. So NumPy is basically a powerful tool when it comes to handling n-dimensional array. When I say n dimension is, okay, let me show you another thing. So this is our list, okay, 1 and 2. What about this? If I have not put it in any bracket, what, and it's simply just 2. So what this is? So without any dimension or dimension, when I say dimension, you consider it as a direction, okay? When it is 2, that is, it has no direction. It is just plain a number. So with anything without a direction is called a scalar, okay? But if it has anything that has direction, so it gets into the category of matrices, okay, or the dimensions. So if it is just a plane, a simple plane, this is a plane, okay, this is a simple plane, okay, plane of paper. So this is x-axis and this is y-axis. So any point on this plane, suppose this point is going to be defined by two coordinates, to one abscissa and axis. So it is going to be defined by x and y together is going to tell the position of this point. Similarly, if we have three axes, x, y, and z, so to find the location of any point here, the location of this point is going to be defined by x, y, and z. So this is 3 dimension, and the previous one was 2 dimension, and this one was 1 dimension, or you can say no dimensions are here. Okay. Similarly, there are more than 2 dimensions as well. So I will not be able to plot it here, but there are more than three dimensions as well. Okay, so when it comes to handling data in such fashion where there are more than one dimension, NumPy is very fast and very strong and powerful. Okay, and when it comes to handling linear algebra, Fourier transformation, or using for any random number capabilities, NumPy is very strong. You can check the documentation of the NumPy as well, or you can go through W3 School or any Java T point for more details if you want to go through. But this is just more than enough to understand. Okay, NumPy is being used whenever there are cases of matrices or arrays. You can use NumPy in that case. Okay, to
So
install.
can you repeat that one? Like you told no, if that if it has direction, it's called matrix. Without direction, uh,
Scalar.
scalar.
Yeah,
Okay,
if it does not have any direction, it is called as scalars.
okay.
So these terminologies, you need not to remember these terminologies. You just need to understand. Okay, there are certain things which, like there is a word called a scalar. It does mean something, but you need not. It's not compulsory that you remember it. If you know it, it's well and good. If you forget it, don't worry. It is not that crucial to be marked up. Okay. So if I come to I said one dimensional array, two-dimensional array, or three-dimensional array. So when I say array, in a layman term, you can picture it as a list, okay? But basically, it is not a list. So let me tell you what is the difference between these two. What is the difference between list and array? So a list, the first example I showed that 1, 2, 3, A, B. So it can have different data types, but array, it will have just one single data type. Okay. For using list, you need not to import any module. Okay. And for using arrays, you have to import separate module for that. Module is basically the packages that are having the, you can consider it as a different Lego blocks. Okay. So if you want to use array, it is a different Lego block and you have to attach it with the Python. To do so, you have to use the command import, and that this array functionality comes in numpy, so you have to import a numpy. Okay, so suppose I want to use a numpy in this, so I will have to write, first I have to install the library. So the syntax for it, pip install -q minus upgrade numpy. Upgrade is basically to, if there is a newer version, it is going to upgrade it. So import numpy. So numpy I'm getting imported in this section, and as np. As np is similar to giving an alias name. So wherever I have to write numpy, I can, instead of numpy, I can write np, and that is a very common name that is being used for numpy. And similarly, I'm importing a block called as time, so that is going to have all the functions, all the functionalities that is going to handle the time variants. So it could be date, time, calendar, timestamp, anything that comes under this. Okay, so let's check the speed part. When I say, so I have made a function with the pure Python, in that I have made a variable time Python, and I have called the time function time.time. Okay, so this is going to capture the current time as soon as I run it. Then I have made a list one, and in this list I have put certain numbers here. So this number is basically 1 lakh. So this is going to be a very big list. Okay. Similarly, I have made another list, list 2, and in that also I have put certain numbers from 0 to this. Okay. Now I'm going to find the sum of these two lists. So list 1 I and list 2. Okay, I'll make it more simple for that, so that it's easier for you to understand. Okay, so what it is doing is it is going to add the each elements from list 1 to list 2, and it is going to store it in another list. Okay, and then I'm going to return time.time. Time.time is basically going to calculate the current time. Okay, so from here it is calculating the starting time, and whenever you run it, whatever the system time it is going to capture it in microseconds as well. So this is time dot time, again the current time minus the previous time. Okay, so this is going to give us the gap, time gap. And then numpy version. Okay, in numpy, instead of range we have to use another command, that is a range. Okay, for numpy package there is also a function that is going to give a range of numbers, but in numpy we call it as a range. Okay, because uh, mostly we deal with arrays, so that is why you can consider it as we have put that word here, a. That's not some good logic, but here just to remember, and as a mnemonic, yeah, we have put as a. And np dot a range, that means inside the mp module, that is numpy module, dot means get inside that and find this particular function named as a range. And in this particular function you put a value of 1 lakh, and whatever the value it is capturing, save it as my array 1. Similarly, another function, another line, we are storing second array 2. Now we are going to add array 1 and array 2. Okay. You remember in normal Python we have list, and in NumPy version we have arrays, and we are doing the same thing, like we are adding each element here. Okay,
Got it.
and then we are finding subtracting. Now we are running it, and let's see if we get that any kind of differences here. So it was already run. You can see the core Python was 0.2417 and the NumPy version took 0.0173. So if you find the percentage, how many times it is faster, you just divide these two, and you can see the NumPy version is 13.9, like approximately 14 times more faster than the normal version in calculation. And if you see the calculation size, the number of calculation it has to go through was approximately 1 lakh. So it is very very fast, and it is very good in handling arrays. Okay, so how to make array? Okay, we were understanding the differences between list and array. So list cannot handle the arithmetic operations directly, and arrays can handle arithmetic operations directly. Okay, one such example is here. So here we had directly used array 1 plus 2, but here in this we have to take each element. I is taking the care of all individual elements in the given list at given address, whereas we just simply write array 1 plus array 2. So this is like good enough indication for it, that it is going to add each element at zeroth element, like zeroth is going to be added with the zero, first is going to be added with the first one. Okay, there are more things to compare, but you can always go and find it on W3 School. Now let's take an example, creating a Python list. We have made a list out of there, and to check the type, we write type command, type my list, and this is going to give us the what type of data is this. So it is going to return us class list. So class list basically, just a second. Okay, so class list is basically this type list type, and then my list is going to give us what type of data type we are handling right now. So my list is basically a list, and we have printed it, it's 1 2 3 4. Okay, so one dimensional array using a Python list. So to make an array we use command array. Okay, so currently it was list. Now if we pass this list to np.array, any function that is inside np or numpy is called by the command np dot. So if you want to see what are the different commands inside it, just type np dot, and it should give us suggestions here. These all are the functions that you can use inside it. Okay, so these are different functions that you can use it. Okay, so to make it this particular list as array, we pass it through a function called as array, And now the data type, it is
So is it
getting,
because if we pass through array, it will become faster, or
yeah.
okay?
So this is a technique of making a list into an array
Got it.
so that operation become much more easier in
Faster.
future terms. So now since I have converted it into array, it's time to check whether it has changed or not. Earlier it was list. You can see here the list. Now it should have changed to, we have got an array, arr np.array my list. Okay, it's not defined yet. Let's run this and then this. So I'm installing Numpy in this. Okay, now I'm installing in this, import Numpy as np. Now it should give us the result. Okay, so now the class is nd array. Nd is basically n dimensional array. Okay, so this is one, two, this is like one dimensional array. So this is, okay, this is one list, and I'm adding one more list inside that. So it's become two lists. To see how many lists are there, so you can just count the number of consecutive brackets, closing brackets or opening brackets. So this is two dimensional and this is three dimensional. Okay, so this is row one. Okay, in this, if you consider this two dimensional matrix, so this is one, this is row one element one, and this is row two element one of column one. This is row one column two, and this is row two column two. So that way you can check the address also. So this is my matrix here. Okay, and if you want to convert it into array, so best way is to pass it through the function np.array, and then you can check the matrix. So now if I run it, you can see it has converted to np.array. Earlier it was a list inside list. Okay, and now after passing it through array function, it has converted to array. So these are sometimes used for handling images, and if you can if you consider the big table with different RBG values, okay, in each cell, so it is going to give us the color intensity in that particular cell. So it is like three values in one cell, so it is a multi-dimensional feature. So you can use that to color or as a pixel. Okay, whenever you have a photo on your screen, each you can divide your whole screen into multiple cells, and each cell will have three different values: RGB, red, green and blue. So if it comes to NumPy, it handles it very easily and very efficiently and fastly. So that is the one use case you can understand. Okay. So let's see, there are three different functions. Now we are going to use dot shape, dot endim and dot d type. Okay, type was basically used to get the type, what the data type we are having here. So if this is going to give us ARR, so earlier we made ARR and converted my list 1 2 3 4 5 into array, and now we are checking, so it is nd array. Okay, this is another list, and if we convert it, it is going to give us, it is converted as array. So you see this is converted as array. This is row 1 column 1, row
Got it.
2 column 1, row 3 column 1, row 4 column 1. Similarly, if you print it, you can see these all are different elements of different rows but same column. Now we are going to use the function dot shape. So what it is going to give us. Okay, now you see the first one here, when it was array here, so this is 3 to 5, total 5 elements are there. So it is giving us 5 comma, so that is 5 elements are there, but only one rows is there. Okay, only one row is there. But if we go for the matrix, it is giving us 4 comma 3. That is, it is giving us the dimension row cross column. How many rows are there, how many columns are there? That is called as shape. Sorry. Then we have another function called as ndim. So ndim is basically going to give us what dimension it is. Okay, the first one here is this element is like, suppose if I want to get 4, okay, so I can print arr 0, sorry, arr 0 is 1, arr 1 is 2, arr 2 is 3 index. So only one index is required to print that particular item. So if I print here 3, so it is going to give us 4, you see. So if you want to print a given element in that, you just have to write one digit here. So that is good enough to give the location of that element, and it will give us the answer. For a two-dimensional array like this, you have to give row and column, so it will give us the position of that particular element. So if I want to be this 5 to be printed, I'll write what is the row, sorry, so row is 2, okay, row is 2 and the column is 2. Oh, sorry. Row is 1 and column is 1 because start counting from 0, right? My bad. So 0 and 1. So for 5 we have to write 1 1. So dimension is basically going to tell us how many numbers or how many variables you require to uh, give as an input to find the position of any element. Okay, so you see in this case here we need a row and column, that is two values are required to find the location or define the position of any element. Okay, similarly in this case only one element is required, or only one number or one dimension is required to locate the element. So ndim is basically giving us that number. So how many parameters are required to define the location or the index of any given element. So this is going to give us matrix. Mat is basically two-dimensional. Now if I write one more thing here, let me take example of three-dimensional also. How we can do that? Let's transform this. We name it mat3, and here also mat3. And if you print here mat3, what we are going to get is, see this, and if we find here mat3 dot shape, so it is giving us 3 1 3 3, one row 3 column. And if we write here 3, so it is giving us 3-dimensional. So to understand, you can count the number of closing brackets or opening brackets, continuous closing. So to find the position of this 3, we have to give 3 different values to find that value. Okay, 3 different indexes to give that address. Going back to uh, initialization, like a range function, a range is basically going to give us, if we exclude a part, so range is basically going to give us a range of certain numbers. So normal Python is having a function called as range, and for NumPy we have a range. So this is going to start from 0 up to 10 with a jump of or step count of 1. Okay, so let's run this. So it is going to give us 0, 1, 2, 3, 4, 5, 6, 9. Now if I change it to 1.5, so it is going to give on the steps count of 1.5. So 0, 1.5, 3, 4.5, and like this way. Okay. Similarly, if we give a step side of 2, we are going to get even numbers. So there is another function called as zeros. So zeros is basically used to get, you have to pass a function like value shape size. Okay, so what is the shape of this? So it is going to give us a set of zeros, 4 zeros like this. Okay, if you want two-dimensional, you have to write in the shape itself, you have to write 2 different arguments. So 3 cross 3, so we are going to get 3 cross 3 matrix of zeros. So 0, 0, 0, like 3 rows and 3 columns. If I change it to 2, so I'll get 3 rows and 2 columns. Okay, 3 rows and 2 columns. So this is zeros function is used to get zeros. Okay, similarly ones function is used to get 1 instead of 0, and linspace is basically function that is going to give us linearly spaced numbers. Okay, so in that you have to write the starting number from where you have to start, and the stopping number, like up to what number, and how many numbers you want. Okay, so that is way. So if I give linspace start is equals to 0, stop is equals to 5, and num is equals to 10. So from 0 to 5 it is going to give us 10 numbers. So first number becomes 0, second becomes 0.55556, and similarly we get 10 numbers. Okay, one such use case is, suppose we want to find, we are going to plot a number x is equals to, and we use a function sine function, and in this sine function we can pass this above statement, so it is going to give us a list of those numbers. So this is just one way how you can use. So it is going to give the sine value of these numbers, that is starting from 0 to 5, and all those 10 numbers values are here. Okay, so then we have e. So this is going to give us identity matrix. Identity matrix is a matrix in which the left diagonal is equals to 1. Okay, and other elements are 0. So this is left diagonal, so this is 1, and other elements are 0, so this is I element. Okay,
Left is one and
so left diagonal elements are 1, and other all elements are 0.
zero.
Yeah,
Okay.
then we have random array. So for sometimes we do not have a set of numbers, we just want some randomly numbers to be picked here. Okay, so let's understand in a use case example here, generation of a passcode. Okay, every time you log in, there is an app that gives us a passcode that you enter as a passcode, and it keeps changing every 30 seconds. So you can generate that number by random function. So for that we use dot random dot rand function. So this is going to give an array, okay, of random numbers. So for this case, let's use it np dot random dot rand, and we are passing 5. So let's see what it is going to give us. So it has given us 5 different numbers, okay, 5 random numbers, okay, and that too between 0 and 1. Now if I run it again, shall we get, see, the number has changed. Every time you run it, you are not going to get the repeated numbers. Now if I want this to be multiple of 100, you can just multiply it with 100 and round it off to get a 2-digit number. Similarly, if you want a matrix of random numbers, you can just give it as a two-dimensional number, 2 cross 2, 2 comma 2. Rand n, what is the difference between rand and rand n? So n is basically going to give us standard normal distribution of mean 0 and variance 1, okay. So this is going to give us normalized numbers, and this is going to give us just plain random numbers, okay. So this is going to give us 4 cross 4. Then we have a function called as reshape, okay. Shape was like, if you remember, what is the shape of my matrix? It could be 2 cos 3, how many rows and how many columns. But if you want to change the shape of your matrix, you can change it, okay. So here I'm generating a random array, okay, of 6 numbers, okay. This will be a simple plain one-dimensional array, okay. And then we are finding the dimension of it, and then we are using reshape function and dividing it into new shape as a 3 rows and 2 columns. And remember that the product of this two, that 3 into 2, should be same as this, because this is basically the number of elements. Suppose, let me show you here. Now if I change it to 1, so earlier this was this, okay, a straightforward one dimensional array. Now it has converted into 3 to 2. Now if I do it 3 into 1, what's happening here is it is throwing an error. What error? Because cannot reshape array of size 6 into 3 into 1. 3 rows and 1 column. In 3 rows and 1 column can accommodate only 3 elements. But how many numbers we have total? It has 6 numbers. So we are trying to adjust the shape from this 6 numbers to only 3 numbers. So that is not possible. So this is important to note that whenever you do the reshaping, the size or the number of elements, all the number of elements should be taken care of. So here we have 6 elements, and
It should be like same or higher, right?
it should be same.
Okay.
Yeah, let me show you for the higher number, 3 cross 3. Now if I run it,
Suppose if I run higher, what will happen?
error,
It will again
because
throw
you
error.
only
Okay.
have 6
I can't.
elements and you
Okay.
have to
Got it.
fill for 9 places, so that's
Got it.
not possible, right? So you have to just give the exact numbers, and it is going to fill on all the places in that case. So indexing is basically very simple, like you used to do earlier in the previous example. Also I showed like how you can get the like element 5. So if it is two-dimensional array, dimension is basically going to tell you how many numbers you need to define the position of that particular element. So to do that, you also like you have to give the address in that case also. So suppose 0 to 1 11, we are going to get a range of numbers with a jump size of 1. So we have it as 0 1 2 3 4 up to 10, okay. Now we are slicing it. Sorry, I think I moved here. Yeah, I was going through indexing. So 0 to 11, and my array 1, it is going to give us the first element. 0 1 2 3. So counting always starts from 0, okay. So my array 1, it is going to give us the first element. And how to do it for two-dimensional? You just have to add one more square bracket here. If it was two-dimensional, you have to add one more square bracket here, and you can find the answer to that. Slicing is basically giving two different addresses that you want from this particular location to that location. So here it says that start from location 1 to location 5 and print all those numbers. So it is going to give us 1, 2, 3, 4, and 5. So fifth is not included here because it is going to give us up to 5. Okay, not the 5 but up to 5, less than 5. Start from 1 and end before this element. So start from 8th and end up to, so if the end position is not given, it is going to take up to the last. Okay, so from 8th, that is 8, 9 and 10, because 10 was the last, it is going to give us the last element. If we do not write the first element, starting position is not given here, so it will start from the beginning, that is 0, 0 to 5. So NumPy arrays are mutable. Mutable means you can change the values. Okay, so it is telling that we are changing all the elements from 0 up to 5 with a value of -5. So earlier it was 0, 1, 2, 3, 4. Now it is going to be -5, -5, -5 up to fourth element, that up to 4, and then we have other elements at previously, like it was in previous case. Now we are changing, making a new 2D array, 0, 1, 2, 3, 4, 5. This is the way you can make an array. Okay, I'm printing that array. So to access the element here, suppose I want 6 here. So 6 is basically third row, so -1, so it is basically 0, 1, 2, second row, and first column, that is 0th column. 2 comma 0 is going to give us 6. Similarly, if we want 11, so it is basically 2 comma 2, sorry, 3 comma 3, because the counting starts from 0. So this is going to give us 11. What's the wrong here? Oh, sorry, we don't have 3 here. Maximum row is 0, 1, 2, 3 row, and we have 2 columns. Index out of bound means you are searching the element beyond the size of your array. That is the meaning of this particular array. So if you get index out of bounds error, that is basically you are trying to access an element which is beyond the given dimension or the shape and size of that array or that matrix. You see, I got 11. So you can also access a sub matrix from here. So if I want 0 to 2, 0, 1, 2, and this many rows, and 0 to 2 again here, 0, 1, 2. So this is going to give us this upper portion here. You can also find the sub matrix here. So 2 is not included, so that is why we are just having up to 1. Okay. And if you do not give it the first position, it is going to take from 0, 1, 2, 4, 5. Now we have conditional array indexing. So on the basis of certain conditions, like array greater than 2, here it's the condition. If the array value is greater than 2, it is giving us true, otherwise it is going to give us false. Okay, so this is just mathematical or any other operation, relation operator is being applied directly on the array elements. So array greater than 2 is basically going to search, like if the array element is greater than 2, it is going to give us true, otherwise it is going to give us false. So here false, false, and then true, true, true. Okay, now if you want to find the length, you can use len function. Length is 13. And one more thing, if you pass this, okay, if you pass this, if you want to print this, sorry, if I print this, the name of my array was array. Okay, now if I print this, what it is going to do is it is going to print me Sorry. Okay. So this is my list, okay? List of true and false values. So this is going to be passed as an input to array. Okay, this is being passed as input to array. So what it is going to happen here is whenever there is true value, it is going to consider it as a, like okay, print that. If it is true, print that. So for first it is false, so it will not print 1. Second, it is false, it will not print 2. But third, fourth and fifth, it is true, so it is going giving us the result. So these are one of the basic examples where you can use numpy. There is another concept also called as numpy broadcasting. So it is like simply, let me show you here. So we have this particular matrix here, 0 0 0, 10 10 10, 20 20, 30 30. And if you add this 0 1 2, so it is what is going to happen is it is going to add this to each element here, and we are going to get 0 1 2 10 11 12. So it is going to add 10 with 0, this second 10 with 1, and this with 2. Now second example is we have 4 cross 3 matrix, and here we have one row and three columns. So how it is going to broadcast? So what numpy is going to do is numpy is going to change this smaller matrix into the shape of this matrix. So it is going to change it into the shape of this matrix, and it is going to add it. And also remember that when it is changing this into this format, the earlier format, so it is going to replicate the same value in all the rows. You see 0 1 2 0 1 2 0 1 2. So it is going to give us the same result here. Otherwise, if we have just one single column and one single row and you want to add it, okay, so what it is going to do is it is going to broadcast this number of rows. These three columns are going to be broadcasted in a downward direction, and this is going to be broadcasted in the row side direction here, like column side, and this is row side. So it will become something like this: 0 0 0, 10 10 10, 20 20, 30 30, and then this is for this, and we are getting the same result. So this is a facility that is available with numpy. It can give us results in such scenarios also. Okay. So there are certain mathematical function that can you can use with numpy. First is min function max, then argmin is going to give us the indices of minimum value, or you can say the position or the index of the minimum value. Similarly, we can get the maximum value index, sqrt, that is going to give us square root, and then mean, and then exp is going to give us the exponential of that e to the power that number. Okay, then we have some function to change the shape like we did earlier. We can change the shape of a given array. Flatten is to earlier we had one dimensional array and we changed it to 3 cross 2. Now again we want it into one single dimension, then we can use the keyword as flatten. Transpose is going to change the rows into columns and columns into rows. So let's see this example here. So I'm making an array of 15 numbers, 0 to 15. Now I'm changing it into 4 cross 4. We are using a reshape function, so it is getting converted into this format. Now the work is done. Now again I want to flatten it, so I'll use dot flatten, and again it will be converted into row wise. Okay. Now again let me run this. Okay, the array is this 0 1 2 3. Now if I use transpose, what it is going to do is, you see the row has changed to column 0 1 2 3 4 5 6 7 8 9. This So this function is to transport, it converts the rows into column and column into rows. Then we have merging and splitting of different arrays. So we have two arrays here, array X and array Y. That is, and let's print this two array, 2 cross 4 arrays are here. Now we have a function called as concatenate, np.concatenate along the axis 1, that is column wise. Okay, so it is going to concatenate like 1 2 3 4 5 6 7 column wise. So it will add these elements as new column, so 21 25 22 26. So it is like concatenation in column wise. If you give axis is equals to 0, it is going to add it in the bottom side, that is row wise. So 1 2 3 4 5 6 7 8 and 21 22 23 24 in the next row. Okay. So this is splitting into different arrays. Okay, so this was horizontal split. Okay, and now we also have as vertical split. So this was the name of my array, and from what index or position you want to split. So it is splitting against second position. So that is these are the different functions that you can always use, and I'll not say you to just like mug it up, but just understand that okay, these are the functions available, that numpy when it is come, like it has the facility to handle arrays and matrices in a better way. So if you like if you have to use these kind of things in your program, it's better to prefer using it through numpy rather than using just normal python.